When excavation teams started digging through the Iraqi desert in the early 1900s, they expected broken pottery and crumbling walls. What they found would force us to question everything we think we know about human progress. Buried beneath ancient Babylon were traces of engineering so advanced that modern experts struggle to explain how it was possible 4,000 years ago. The story you learned in school is simple. Humanity crawled slowly upward from primitive savagery. Sticks and stones, then bronze, then iron, and finally the modern world. Ancient people were clever, but fundamentally limited. They had no understanding of chemistry, physics, or complex mathematics, but that story is incomplete. And Babylon is where it falls apart. Researchers started finding objects that didn't fit the timeline. A corroded jar here, an unusual pipe there. Easy to dismiss as anomalies. But as excavations expanded, these anomalies became impossible to ignore. They were finding technology, not alien spacecraft, but real, practical innovations that solved everyday problems using principles supposedly not discovered until centuries later. Conventional wisdom says Babylonian life was harsh and primitive. People dumped waste in the streets, buildings were dark and smoky. Water was hauled by hand. Lighting meant choking on torch smoke. That's what the textbooks say. But beneath Babylon's streets, engineers found something completely different. A city designed with sophistication that rivals modern urban planning. The turning point came during a 1920s excavation near the Euphrates River. A German team was documenting a merchant's house when an engineer noticed something odd: too many hollow spaces in the floor. Unusual gaps between foundation stones. These weren't construction floors. They were channels. A deliberate network running beneath the entire residential quarter. At first, they assumed it was basic drainage. But as they traced these channels, they discovered something shocking. The system wasn't just carrying waste away. It was delivering fresh water under pressure. Pressurized plumbing. The kind that requires understanding fluid dynamics, precise measurements, and hermetic sealing. According to every history book, this didn't exist until Roman aqueducts at the earliest. Yet here it was in Babylon, perfectly preserved in terracotta and resin. When metallurgists analyzed the pipe joints, they found sealant made from natural bitumen, mixed with crushed minerals in exact proportions. Someone understood material science well enough to create a compound that withstood constant water pressure for decades. They found ceramic valves that could regulate flow and prevent backflow. A concept textbooks credit to 18th century European inventors. The academic world had two choices: admit the historical timeline was wrong, or explain these discoveries within the existing framework. Most chose the second option. They got lucky. It was simpler than it looks. Further study is needed. But the engineers weren't buying it. They'd measured the angles, tested the materials. This wasn't luck. This was knowledge. And plumbing was just the beginning. As excavations continued, the list of impossible discoveries grew. Optical lenses ground to precise specifications. Corrosion-resistant metal alloys. Acoustic chambers designed with mathematical precision. Mechanical devices with gears and bearings. Each find raised the same question: how much did they actually know? What was found beneath Babylon suggests our ancestors weren't primitive people stumbling through darkness. They were engineers, scientists, innovators, and somehow their knowledge was lost to history. The question is, what else did they know that we've forgotten? The plumbing system was just the beginning. What researchers found next would reveal that Babylon's engineers understood principles of physics that wouldn't be formally documented for thousands of years. During excavation of the central district, a heavy rainstorm caused part of the ground to collapse. When workers investigated the sinkhole, they discovered a sealed chamber that had been hidden for millennia. Inside was a room unlike anything they'd seen before. The walls were curved at precise angles. Along the perimeter stood tall clay vessels, each one positioned with mathematical exactness, their openings all facing the center. Standard archaeological interpretation said these were storage jars for grain or wine. That's what the textbooks claimed. Simple containers, nothing more. But when a researcher stood in the center of the room and spoke, something extraordinary happened. His voice multiplied in volume, echoing back with perfect clarity, as if amplified by invisible speakers. The acoustics were intentional. Every angle, every curve, every jar placement had been calculated to create a natural amplification system. This wasn't a storage room, it was an ancient sound engineering marvel. In the city of hundreds of thousands, leaders needed their voices to carry authority without strain. These acoustic chambers solved that problem using nothing but geometry and clay. Pure physics, applied with precision. Another mystery emerged when teams began mapping the palace interiors. The deepest halls had no windows, no openings to the outside. According to conventional history, people worked in such spaces using oil lamps and torches. But archaeologists found no soot, not a trace. The ceilings were pristine, the walls clean. If fires had burned here for years, everything should have been black with carbon residue. Then they found the answer in an interior courtyard. A system of polished bronze mirrors mounted on adjustable stands. Each mirror was positioned to catch sunlight and redirect it through corridors into the windowless rooms. It was a light relay system. Sunlight bounced from mirror to mirror, traveling deep into the building's core, illuminating spaces that should have been pitch black. The Babylonians had created a solar lighting network without any need for fire or smoke. In residential quarters, excavators discovered something even more remarkable: a stone bathtub with two pipes. One brought water in from above, the other drained from below. Standard history says ancient people poured cold water over themselves from buckets. Heating water was supposedly a long, difficult process reserved for the wealthy. But beneath this particular tub was a small chamber designed to hold smoldering coals. The heat rose through the stone, warming the water in the bath above. It was an ancient water heater, a working boiler system built into a private home. The homeowner could enjoy a hot bath after a day's work simply by lighting a small fire in the heating chamber. This level of domestic comfort supposedly didn't exist anywhere in the world for another 2,000 years. Even the kitchen revealed advanced thinking. Researchers found copper pots lined with a thin layer of silver on the inside. Textbooks describe this as decorative, nothing more than aesthetic choice. But silver kills bacteria. It keeps water fresh longer and prevents food spoilage. The real innovations were found in the workshops. This is where Babylon's technological sophistication becomes impossible to ignore. In a metalworking quarter, archaeologists uncovered saws and drill bits made from an alloy showing no corrosion after thousands of years buried in sand. According to official history, ancient metalworkers only had soft copper and bronze. Rust-resistant alloys supposedly didn't exist until modern chemistry. Laboratory analysis revealed a precise mixture of copper, tin, and trace metals, creating exceptional hardness and corrosion resistance. Someone had mastered alloy chemistry without the periodic table. The real shock came when examining stone blocks these tools had worked. Under magnification, the cut marks contradicted accepted history. The grooves were too uniform, too deep, too precise. Modern stonemasons examining the evidence agreed these marks came from rotating cutting tools operating at high speeds. Something mechanical. If true, Babylonian workshops had powered cutting devices. Mechanization supposedly didn't exist for another 3,000 years. In another workshop, researchers found bronze gears with interlocking teeth, part of a larger mechanism that had been dismantled. Conventional history says complex geared machines appeared in ancient Greece, becoming common during the European Renaissance. But these Babylonian gears were older, much older. They showed evidence of regular use, not experimental prototypes. When engineers reconstructed the mechanism, they realized it was probably a calculating device designed to track astronomical movements. The Babylonians were famous for astronomical knowledge. Now it was clear they'd built machines to help with those calculations. A bronze computer, thousands of years before mechanical calculation supposedly existed. Chemistry laboratories revealed another layer. In wealthy homes, archaeologists found ceramic vessels containing residues of acids and metallic salts. Standard textbooks claim chemistry began with medieval alchemists. Ancient peoples supposedly only used natural materials in raw state. But chemical analysis told a different story. The compounds required controlled reactions and precise temperature management. The most likely use, electroplating, coating base metals with thin gold or silver layers. If Babylonian jewelers used chemical deposition instead of hammered foil, they understood oxidation, reduction, and ion transfer at a practical level. That knowledge wouldn't be formally documented for nearly 4,000 years. Outside the city, along canal systems, excavators found the most impressive automation yet. Water-powered mechanisms with wooden and bronze gear trains. These weren't simple water wheels for grinding grain. They were complex machines with multiple gears designed to automate irrigation across vast fields. According to historical timelines, such sophisticated gear systems appeared in Greece, centuries after Babylon fell. Yet here they were, embedded in Babylon's agricultural infrastructure. Automated irrigation meant farmers spent less time moving water manually. It freed human capital for other pursuits. This explains how Babylon supported large populations of scholars, artists, and craftspeople. The civilization had mechanized its most labor-intensive tasks. These weren't lucky accidents. The evidence kept mounting, but the most impressive engineering wasn't in the workshops or laboratories. It was built into the city itself. Babylon wasn't just a collection of buildings, it was a designed ecosystem, engineered to support hundreds of thousands of people in the middle of a desert. When archaeologists began excavating residential districts, they discovered vertical shafts descending deep beneath the streets. At first, they assumed these were wells or storage chambers. They were wrong. The shafts connected to horizontal tunnels that formed a network running under entire neighborhoods. At the bottom of each shaft was water, fed by hidden underground channels. This wasn't a water storage system, it was air conditioning. When hot desert air entered the shafts, it hit the cool water at the bottom. The temperature drop created pressure differences that pushed cooled air up through vents into homes and public buildings. Natural convection, evaporative cooling, climate control without machinery. While surface temperatures in the Iraqi desert regularly exceeded 40 degrees Celsius, Babylonians could rest in rooms kept comfortably cool through pure engineering. But the system got even more sophisticated. Inside some ventilation shafts, excavators found layers of copper mesh and plant fibers treated with antimicrobial compounds. These were air filters. The mesh caught sand and dust particles before they could enter living spaces. The treated fibers killed airborne bacteria and pathogens. Standard history claims that understanding air quality and filtration emerged in the 20th century with modern medicine and industrial pollution. Yet here was a civilization implementing citywide air purification 4,000 years earlier. They understood that desert air carried more than just heat. It carried particles that could damage health, so they engineered solutions. In the commercial districts, researchers made another discovery that challenged conventional fire safety history. Wooden shelving units coated with a substance that wouldn't burn. When they tried to ignite samples in laboratory conditions, the coating merely darkened. It didn't catch flame. Chemical analysis revealed a complex mixture of mineral salts and organic binders, creating a fire-resistant barrier. Official history says fire-retardant materials are modern inventions developed in response to industrial fires and building codes. But Babylonian merchants were already protecting their goods and documents from the city's most common disaster, fire in densely packed buildings. The urban planning itself showed remarkable foresight. When excavators mapped the city's layout, patterns emerged that modern urban planners immediately recognized. Streets weren't random. They followed a grid designed to maximize airflow and minimize heat buildup. Building heights were regulated to prevent one structure from blocking another's ventilation. Public spaces were positioned to create wind corridors that pulled cool evening breezes through residential areas. This wasn't accidental. Someone had mapped wind patterns and designed the entire city to work with desert climate, not against it. Perhaps most telling were the public fountains. Not decorative displays, but functional cooling stations positioned at calculated intervals throughout the city. The water wasn't just for drinking. As it evaporated, It lowered ambient temperature in surrounding streets. The fountains were strategically placed to create zones of cooler air along major thoroughfares. Evaporative cooling at urban scale. Climate engineering using nothing but water, stone, and understanding of physics. Modern cities struggle with heat island effects, where dense construction traps warmth and raises temperatures above surrounding areas. Babylon solved this problem millennia ago. Every system worked together. Ventilation, filtration, fire protection, urban design, water distribution. Not separate projects, but integrated infrastructure planned as a unified whole. This wasn't trial and error. This was systematic city planning based on deep understanding of how air moves, how heat transfers, how water cools, and how humans thrive. The city was designed to be livable, and it worked. For thousands of years, the infrastructure was impressive. But infrastructure doesn't build itself. Someone had to know how to design it. Someone had to measure, calculate, and plan. The tools for that knowledge turned out to be just as sophisticated as the systems they created. In what appeared to be a surveyor's workshop, archaeologists found bronze measurement instruments that rivaled modern precision tools. Calibrated rulers marked in units so fine they required magnification to read clearly. Leveling devices using liquid-filled chambers to ensure perfect horizontal alignment. Angle measurers accurate to fractions of a degree. According to conventional history, precision measurement emerged gradually, reaching high accuracy only with industrial manufacturing in the 18th and 19th centuries. But these Babylonian tools were already there, measuring with accuracy that modern construction workers would recognize and respect. How do you build underground ventilation networks that work across an entire city? You measure precisely. You calculate exactly. You plan systematically. The evidence was in their hands the whole time. Even more remarkable were the astronomical records, not observations scribbled casually, but systematic data collection spanning centuries. Clay tablets covered in numerical tables, tracking planetary positions, lunar cycles, and stellar movements with mathematical precision. These weren't approximations. The calculations were accurate enough to predict eclipses years in advance. They tracked Venus with precision, matching modern astronomical models. Standard history acknowledges Babylonian astronomy, but usually frames it as religious observation mixed with basic mathematics. The tablets tell a different story. This was science. Systematic observation, data recording, pattern recognition, and predictive modeling. They were doing astronomy the same way modern scientists do it. Observe, measure, record, calculate, predict, verify. The mathematical tablets revealed even deeper sophistication. Not just arithmetic for commerce, but advanced calculations involving squares, square roots, and geometric progressions. One tablet contained what modern mathematicians recognize as an early form of the Pythagorean theorem, used for calculating diagonal measurements in construction. The theorem is named after a Greek philosopher who lived more than 1,000 years after these tablets were written. The Babylonians had the mathematics. They just didn't name it after themselves. Perhaps most telling was the discovery of educational materials. Practice tablets where students copied complex calculations repeatedly, learning through repetition. This wasn't knowledge held by a tiny elite. It was being taught systematically to enough students that they needed mass-produced practice materials. The civilization had an education system. They were training the next generation of engineers, astronomers, and mathematicians. That's how knowledge persists across centuries. You teach it, you preserve it, you build institutions around it. In one archive building, researchers found something that changed how they viewed Babylonian record-keeping entirely. A bronze plate, thin and precisely crafted, engraved with a detailed map of the city. Not a decorative representation, but an actual surveying map drawn to scale. The accuracy was remarkable. When overlaid on archaeological site plans, the ancient map matched within millimeters. Someone had surveyed the entire city with precision instruments. Someone had transferred that data to a permanent record. Someone understood map-making as a technical discipline. The map included details that shouldn't have been visible from ground level: building layouts, underground channels, water distribution networks. They either had elevation or they had developed another method to create accurate overhead views. Either way, they were thinking in 3 dimensions, planning spatially, creating technical documentation that could be referenced for maintenance and expansion. Modern urban planning uses the same concepts: maps drawn to scale, infrastructure documented, systems designed to be understood by future engineers. Babylon was already doing it. All of this points to something bigger than individual inventions or clever solutions to specific problems. It points to systematic knowledge creation and preservation, to institutions dedicated to understanding the world, to cultures that valued technical education and accurate documentation. This wasn't primitive superstition and trial-and-error construction. This was science, engineering, mathematics, astronomy, education, record-keeping. This was civilization operating at a level we're only beginning to recognize. So what happened? If Babylon had all this knowledge, all these capabilities, why did it disappear? Why did humanity seemingly have to rediscover everything centuries later? The answer is simpler and more tragic than mysterious ancient secrets. Knowledge is fragile. When cities fall, libraries burn. When civilizations collapse, expertise dies with the experts. When invasions scatter populations, institutional knowledge vanishes. Babylon didn't fall in a day. It declined over centuries, conquered repeatedly, its population dispersed, its infrastructure abandoned. Each invasion meant lost records. Each generation without education meant lost skills. Each decade of neglect meant crumbling systems that nobody remembered how to maintain. The tools survived because bronze doesn't rot. The buildings survived because stone endures. But the knowledge, the understanding, the systematic education that created them, that disappeared with the people who carried it. We've seen this pattern throughout history. The Library of Alexandria burned. Rome's engineering knowledge faded during the Dark Ages. Entire civilizations have lost the ability to read their own ancestors' writing. Knowledge isn't automatically preserved. It requires continuous effort, institutional support, and cultural priority. When those things fail, capabilities vanish remarkably quickly. Within 3 generations, sophisticated techniques become lost arts. Within a century, advanced understanding becomes forgotten mystery. Within 500 years, it's as if it never existed. That's what happened to Babylon's engineering knowledge. But here's what makes this story important for us today. We've been telling ourselves a comfortable narrative about human progress. That we're the smartest, most capable, most advanced humans who ever lived. That history is a straight line upward from primitive ancestors to enlightened modernity. Babylon proves that narrative is wrong. Our ancestors weren't primitive. They weren't waiting around for us to invent civilization. They were solving complex problems with sophisticated engineering, creating livable cities, developing scientific methods, and building educational systems. They were doing this thousands of years before we thought it was possible. What we've been calling modern inventions are often rediscoveries. What we've been calling ancient mysteries are usually just lost engineering. The implications are profound. If advanced knowledge existed and was lost before, it can be lost again. Our modern civilization, with all its technology and understanding, isn't immune to the same forces that erased Babylonian expertise: war, climate change, economic collapse, political upheaval. Any of these could disrupt the institutions that preserve and transmit knowledge. We're 3 generations away from losing modern engineering, just like Babylon was. But there's also hope in this story. If our ancestors could achieve so much with basic materials and human ingenuity, what could we accomplish if we combined their cleverness with our resources? If engineers 4,000 years ago could create passive cooling systems that work without power, maybe we should be studying those principles instead of assuming air conditioning must use electricity. If ancient chemists could process materials without industrial infrastructure, maybe there are more elegant solutions to modern problems than we've been exploring. The past isn't just fascinating history. It's a library of tested solutions to problems we're still struggling with. Every time we dismiss ancient achievements as impossible or mysterious, we lose the opportunity to learn from proven engineering. Every time we assume our way is the only way, we ignore thousands of years of human innovation. Babylon fell. Its knowledge faded. But the evidence remains, buried in sand, waiting for anyone willing to look at it honestly, not as impossible mystery, not as ancient alien technology, but as human achievement, engineering, science, civilization, built by people who were every bit as intelligent as we are, who faced difficult problems and solved them systematically, who left us a message if we're willing to read it. The message is simple: we've done this before, which means we can do it again. And maybe this time we'll remember to preserve what we learn.